Alright guys, it turns out that I thought the solution for this problem, and I ended up teaching for spending time, and it turns out that the camera did not record it, so I'm redoing it here. Okay, so that's why you don't see my graph here anymore. Alright guys, so let's do this. So here, given the following graph of damped oscillatory motion, determine the frequency and the time constant. So we are asked what is f equal to what, and then tau, time constant, is what. Okay, this thing is called tau. This is a Greek word. Okay, Greek word tau. Okay. So we are supposed to find the frequency, and we are also supposed to find the tau. Alright guys, so from this graph here, I'm going to read this, I'll make sense probably here. Okay, so how can we find frequency? What frequency really is? Number of complete cycle per unit time, right? So number of complete cycle, number of complete cycle. If we start from here, our complete cycle is really start, go down, and then go up, and then by the time you come to that peak, the cycle is completed. Okay, so it may not come to the same point here, right, all the way up. That has to do with the amplitude, but at least it started from this peak, went down, and then come back again, climbed up to the peak. Okay, so that it will give us what? If we look at the time for that situation, we will get the period. If you look at number of completed cycle, we'll get the frequency, right? So frequency f is 1 over t, right, period. But if we look at in the graph, t equal to what? It's easy to find the t, right? Okay, so you start from this peak. This starts at 0.05. Okay, so at 0, time equal to 0, you start at 0.05. This peak here, that's the position. It goes all the way down, and comes back here to this peak. It comes almost equal to at 0.025 here, and then that time here. So whenever we are talking about the time period, we are looking only in the horizontal axis here, only in the time axis, right? I mean, we looked at on the top, but that top is really to pick out where we want to start. Okay, so 0 to this time here is the time from this, right, is starting point 0 second all the way to, for this object to oscillate and then get to the maximum, next maximum position. That time is a 2 second. Okay, so it is like this here. It looks like this. I'm not going to write the scale here. It's kind of like this though. Yeah. Okay, so this is what we are looking. Our period means this is at 0, right? This is, we have a times in second here, and then all the way from here all the way to this time here. This time gives us the period t. Okay, so that is the t, and then here in this graph it turns out to this 2 second. Alright, let me check whether this camera is recording my video or not, because I don't want to again just teach here and then not have a record. Alright, this is recording. Okay, so that was the time equal to 2 seconds. You may say, wait, because this is a damped oscillation, how do we know period is really true? Let's see, maybe the period has changed if we go from this peak to here, this peak. Okay, so we can look at that, and if it turns out that here also actually, let's say this is started at 2 seconds, right? This peak is at 2 second initial point. It goes all the way down, goes up, and then this point here, the peak is at 4 seconds. So if we want to see here, again the period would be final time, which is 4 seconds minus the initial time 2 seconds. That will give us 2 seconds. So period has not changed. So period doesn't really change. Okay, only the amplitude of maximum amplitude, that value changes. However, period is constant. T is constant, okay? So no matter where we looked at in this graph, we should be able to get the same value of period T here, in this case T equal to 2 seconds. Since we have a period, we can find the frequency. Frequency is 1 over T, which is equal to 1 over 2 seconds. This is really half hertz here. So our value of frequency here is half hertz, okay? That is the value we got. Now, next, so this is done, F. Next is tau. How do we find tau? This is gonna take a little bit longer, so I'm gonna, so please make sure you copy all this information. And then I'm gonna erase this. Alright, I hope you're done with copying. So let me erase this here. Okay, so next step is we want to find what is tau is what, right? So we know we have an equation that contains tau. So let's write that our mathematical model. Xt equal to a e to the power minus t over tau cos 2 pi f t. Okay, let's call this equation 1. Now, well, that's a lot of things here, and we are supposed to find tau. We don't know a lot of things. How are we going to do this? So let's look at this first. We want to find what is this A, right? Amplitude, maximum amplitude. What's the maximum amplitude we have in this graph? Really, we can also really look at here. It's really, if you just look at the graph, it's 0.05. This is the one. But mathematically, how do we find that? So let's do that first, okay, mathematically. So initial condition is at t equal to 0 second, okay? So meaning really at this point, origin, right? So at the t equal to 0 second, wherever we have this lowercase t, we are going to replace by 0 in this equation 1, okay? So it is going to be x. Please look at this first, and then you will get a time to copy it, okay? If you are trying to copy this, just look at here, and I'll give you guys some time to, copy this. So at x is x, wherever we have t, we are going to replace by 0, okay? 0 equal to a equal to minus, in place of t we have 0 divided by tau cos 2 pi f. In place of t we are going to write 0 here, okay? Now we know x at 0, again x at 0, okay? This is not 0, guys. You cannot write this 0. X at 0 is 0, no, not yet, okay? So x not 0 at position 0 equal to a e to the power minus of some 0 is always 1, no matter whatever we have here. So think about it. This whole thing is to the power 0, right? X to the power 0, y to the power 0, or whatever to the power 0 is always 1, okay? So that quantity is 1. Cos, this is multiplied by 0 here, argument is multiplied by 0, that's also then cos 0. So cos 0 is 1, so we don't really need to write anything. So then this x at t equal to 0 is really value of a, okay? So what do we have? Oh, let me write this down. So our amplitude a equal to x at 0. So x 0 is what? What's the value of our x in when t equal to 0? So then at that point we go all the way, we look at the position side, right, at the vertical axis, and at that time we have the value of the position is 0.05. So amplitude is 0.05, okay? So this is amplitude, okay? That's the value of the 0.05 is value of the x at t equal to 0. Okay, so that's the amplitude we have. Now next step is let's look at what else we have instead of saying just add. Okay, so that gave us something here in this equation. Okay, that gave us a. What's the big deal? I mean, we still don't know what, what is this t. How are we going to eliminate? Or at first, how are we going to isolate this tau that we need to find, right? So we have to do something. Here, we have to use the information we already know so that we can eliminate a lot of unknowns here. A few minutes ago, what we did is we calculated a period that has to do with the time, right? So here we are doing this time at 0 second. How about now trying to find this t as the period at 2 seconds? Okay, so what happens? Let's see. So at t equal to capital T period equal to 2 seconds, we want to look at this equation. Okay, again. So let's go back to that equation and let's look at x equal to 2. Okay, I'm writing these 2, guys. You may see somewhere in the book, or I don't know, in somewhere you may have seen this as a t equal to 2 is same as saying x2 here. Okay, so I'm just writing it shorthand here instead of writing t equal to 2. x2 here equal to a. Now a is constant for the given system, so I'm going to just write that down, value 0.05. E is exponential here, right? And minus is same. In place of t, I have now capital T, which is a period, and that has a value. So I'm going to write that 2 seconds here, and then divide by tau. Tau is our unknown, we need to find. Go to cos here, 2 pi. F, what is our F frequency? Is this, can I write in place of frequency half here? Yes, that's what we found, right? That that F was frequency, which is half. Now, in place of t, we are replacing that with the capital T here, which has the value 2 seconds. So I'm going to just multiply that with the 2 seconds here. Okay, so this t here, for here, we are writing this t as capital T, which has the value 2 seconds. That's how we have. So these two guys gets cancelled. All right. So just looking at this equation, this we have here cos 2 pi, this is just now cos 2 pi, which is what? Equal to cos 0, which is equal to 1, which means we don't have to write down more. Now, another information is x2, x at 2 seconds. This is important. So, what is the value of the position at 2 seconds? We have to go back to the graph. So, it turns out the position at 2 seconds, this t equal to 2 seconds here, it goes all the way up. And then if we were to, so it's, maybe I'll show you guys real quick here. So it's like this. 0, then we have a t in second. I'm not going to write down the value, but I just want to give you guys a little bit. So this is at the 2 seconds right now, okay, and this, so we need to look at what is the value of x, what is the value on the vertical axis here, position, when we are at 2 seconds. Meaning, so you just make a dot and take it all the way to the tip here. And then come back here. So this value should give us the value of x at 2 seconds, and then in this graph it turns out to be, I don't know if you can see, it turns out to be at 0.025 because this peak is in between 0.02 and 0.03. Okay, so we are going to write down that value. Okay, I'm going to leave that there for a moment. So this is 0.025 equal to 0.05 e to the power minus 2 by tau. This part is already 1. Guys, let me check this whether it is recording my video or not. Alright, this is still recording, good. Alright guys, so one more, let's look at here. So this is right, this 0.025, 0.05, if you divide this by this, or I mean a lot of things to do. I mean this is just algebra here, right? So what I'm going to do is this. Just bring this whole quantity over here, then it becomes positive, right? If it's negative. So I'm going to just make this like this. Take this over this way, so it becomes like 1 over e to the power minus 2 by tau equal to, and bring this guy and divide here. So this becomes 0.05 divide by 0.025. And then next step is, this is right. So here, this is right, 1 divided by x to the power minus 2. If you have this, you can write this as really what? X is squared, right? If you take this up, then it becomes positive, right? So we are going to do the same thing here. E to the power 2 over tau equal to 0.05 is divided by 0.025. That's really 2 times, right? So this one 2 times, like that. Okay. All right. I'm going to erase this graph here. I need more space. Okay. So next step, we are going to continue from here, go up here. So e to the power 2 by tau equal to 2 is given. Well, this looks much simpler than this whole equation we had before, but still, how are we going to find this tau? It's kind of in a really weird form, right? Excuse me. So what can we do here is this. Have you guys learned about the property of logarithm? So natural logarithm ln y to the power some constant a, right, is same as writing a ln, means natural logarithm ln y. Okay, so we are going to use this property of logarithm, natural logarithm, and then let's take a log on both sides. For this one, for 2, equation 2, take natural log ln on both sides. For in equation 2, if we do that, then it's going to give us this ln e 2 by tau equal to 2, right? Now we can use this property here. So natural logarithm of something to the power something, that this power is what? 2 by tau, that can come in front, and then we are just left with log e, which is equal to 2. Now another property of natural logarithm is log of natural logarithm of e is this is 1. Okay, so since this upside down dot 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 is called since, okay, so we can write 2 by tau times 1, we don't need to write, is equal to 2. Okay, wait, something is missing here, something is not right. Did it come right? Let us see. Let us see, 2 by tau, 2. Okay, so this is okay here. So this is tau equal to 1 second. This is a time constant, okay? So let me recheck this equation quickly here before you guys continue. I thought this should have a different value, okay? I may have messed up. It is possible, but maybe not. Okay, so this is fine. Alright, this is correct. Okay, so the time period, time constant tau is equal to 1 second. Okay, so this tau, if you look at, this tau is actually smaller than the period tau. Okay, so this means the oscillation is going to, die out much quicker. Okay? For example, let's say we had the value of the tau, time constant, very, very large. Then, the oscillation will last forever. Okay? Because it decays quickly, but the oscillation is going to last forever. Alright? Okay, so that is about this damped oscillations. Let me check the time. Okay, so looks like we have a little bit of time. We are going to look at a few things quickly. We are going to look at where do this, damped oscillation is going to be useful, okay, in the next video. I hope you guys have done this part. I'm going to erase this also, okay?